This video is going to cover the first free response question on the review packet. This is 1974B. The first thing we need to look at is the diagram over on the right, because we have to determine the height. We know that we're going to use the formula that the potential energy is equal to mgy, and so we have to know what is y. So if we look at the diagram, what's going on here is we have a pendulum attached to a string. The string is, or beam, or whatever it is, but that is a length of L. Whatever that length is, it's going to remain the same length as we go along the radius. So this is also an L on this side. If it was straight down, that would be a distance of L. That's helpful because we have to know the height. So we're going to look for how high is it at point P, and I'm calling that H final. And then how high is it at the beginning, and that's I'm calling that HO. There are probably other ways we can label that, but that's just how I'm going to label it for now. To do this, we need to pay attention to the theta. And so the sine of theta is opposite over hypotenuse. So that's going to be what I'm calling HO over L, which is up here. So if I move my L over and I multiply it, I get L sine theta is equal to HO. I wrote that down here at the bottom. Now, if that is L sine theta, then this, what I'm labeling as HF, what I'm labeling as HF is going to be L minus L sine theta. And that's what I have here. And then I went ahead and factored out my L, so I get L times 1 minus sine theta. Okay, that is the background for the height, because we need that. Maybe before we go any further, we should talk about question A, which is a free body diagram. If we look at what I have here, obviously we have the pendulum, the ball. It has the force of gravity, and it also has the tension force. Those are the only forces that are acting on it. The next thing we should do is set up an LOL chart, because when it is at the top of the arc, it does not have any kinetic energy. It's going to stop for a second as it goes up there. However, it has a lot of potential energy. And when it gets to the bottom, well, that's actually not the bottom, because we're talking about what's going to happen at point P. So when it gets to point P, it has some kinetic and some potential. We just don't know exactly how much of each. So we're going to use this to set up our equation so we can solve the problem. So kinetic energy is 0. U is potential energy, that is mgh, or mgy. I'll call it y. That's what it's called on the AP sheet. That should be equal to kinetic energy, which is 1/2 mv squared, plus potential energy, which is mgy again. Now, these are not the same y's. This y over here is the y at the top, which I'm going to call y initial, or y sub 0, or sub o. On the other side, I have the final velocity, and I have the final height. So those are not the same. We need to distinguish those. Let's go ahead and cancel out our m's, because we know we could factor out that m out of everything. And so now what we're left with is g, which is g, and y sub o. And y sub o is L. It started out here as the whole height. So that is L plus 0. On the other side of our equal sign, we still have our 1/2. Our velocity, that's what we're looking for. And then we have our g and y sub f. So we have our g, and now y sub f is L times 1 minus sine theta. That's what we came up with over here. So I'm going to write that as times L times 1 minus sine theta. Now I'm solving for v, so I need to move this over to the other side. So I'm going to have GL from before minus GL times 1 minus sine theta is equal to 1/2 VF squared. Now, I can also factor out a GL, so I'm going to do that. And so I've got a GL times 1 minus, here we have another 1, but now we have got a parentheses 1 minus sine theta is equal to 1/2 VF squared. I'm running out of space, so I'm going to come over here. I need to distribute that negative sign, and that's one thing on the review packet that I post as a PDF that I actually forgot to do. So we have to distribute that negative sign because now what we're going to have is GL times, now this is 1 minus 1 is 0, and then we have minus a negative, so that's a positive. So we have GL sine theta. Now I want to isolate my VF, so I'm going to multiply by 2, and I'm going to take the square root, and then that is finished. So that is the end of problem 1974b1.